Let's turn now to problem 17. In this problem, we are given the areas of cross sections of a pancreas that are equally spaced apart. Namely, they're spaced 1 centimeter apart. And the pancreas in the CT scan is 12 centimeters long. We have 13 cross-sectional areas spaced out 1 centimeter each. And so these cross-sections measure 0, 7.7, 15.2, 18.0, etc. square centimeters. We are asked to use the midpoint Riemann sum with 6 terms to estimate the volume of the pancreas in cubic centimeters. So the basic principle that we will be using in this problem is that to calculate the volume of a solid, we can integrate the area of the cross section. This principle is very similar to the principle we use to calculate areas of regions by integrating the length of the cross section. So this is actually exact same principle, but taken into one dimension higher situation, where you have a three-dimensional solid or object in 3 dimensions. If you slice an object like this, for example with a knife, and you look at the cross sections, they would be regions. And so rather than having length, they would now have area. The area of a particular cross section will depend on the position of that cross section and will typically vary with the position. And so to find the volume, we need to integrate the area of the cross section. Now here I schematically drew an x-axis which runs the length of the pancreas. So the pancreas is situated between x equals to 0 and x equals to 12. And I also indicated the points where the slight cross sections that were whose areas we have. Namely, the cross sections are taken at points 0, x equals to 0, x equals to 1, x equals to 2, etc. And we have 13 areas like this. Okay, so now since we are asked to use midpoint Riemann sum to approximate this volume, to approximate this integral that calculates this volume, we need to subdivide the interval of integration, which is in this case the interval from 0 to 12, into 6 segments, 6 sub-intervals of equal length. Each of these sub-intervals will have length 2, right? Because 12 divided by 6 is 2. And so, for instance, our first subinterval will run from x equals to 0 to x equals to 2. Here in the picture, I've indicated those subintervals in yellow. The first subinterval goes from 0 to 2, second from 2 to 4, third from 4 to 6, etc. And that's going to give us 6 intervals, each of length 2. Now, we are told in the instructions for this problem to use midpoint Riemann sum. What does that mean? It refers to the selection of the point for each subinterval, where we're going to look at the value of our function that we're integrating. In this case, we are advised to take midpoints of these segments. The first segment has a midpoint x equals to 1. Second segment has the midpoint x equals to 3. Then the third x equals to 5, and etc. So we're going to look at the value of our function. And what is our function? Our function is the area of the cross section. So the value of our function that we're integrating at the evaluation point taken from the first segment is the value of is the area of the cross section at x equals to 1. That is the second number in the list of numbers that we are given. So in other words, 7.7. Then we need to skip one number to go to the area of the cross section at x equals to 3. That's going to be 18.0. And so you can see the pattern now. We are actually going to look at our list of numbers, and we're going to select 6 of those numbers, skipping one at a time, skipping over one number in our list each time we go to the next one. And so these areas of these cross sections would then have to be multiplied by the length of each subinterval. All subintervals have the same length, namely 2. And so we can now write that our volume of the pancreas will be approximated as follows: 2 times 7.7, that is the area of the cross section at x equals to 1, then plus 2 times 18.0, which is the 18.0 is the cross section area at x equals to 3, etc. And let me see if I can pull up the complete list of these areas. The last one we're going to use is going to be 2.7. Okay, so the last one's going to be using is 2.7. So I would put ... plus 2 times 2.7. Now you can factor out 2. And so it's going to be 2 times 7.7 plus 18.0 plus 10.0 plus 8.7 plus 5.5 plus 2.7. I think that, yeah, that is 6 terms. Now plug this into your calculator, and the problem is asking us to round. Yeah, let's round it to 1 decimal place. So that will come out to be 106.8 cubic centimeters. Okay, so that's how you will approach this problem. Of course, that is not the exact volume of the pancreas; it's only approximation. Because essentially what we're doing is we're assuming that for the first interval of length 2, if we took a cross-section on that first interval anywhere else, not at x equals to 1, but anywhere else on that first interval, we're sort of assuming that it would give us exact same area for the cross-section. Of course, that's not going to be the case in reality, and so when we're doing this approximation, we're making an error. Okay, but for this approximation, our answer would be calculated this way.